Welcome. I would like to take you through one of an example from chapter 10, and I'm just going to use one of your homework problem to show this. Now, in chapter 10, we are talking about valuation and rates of return, and therefore key objective is to be able to determine the price or the value of a financial instrument. So in this example, you're a financial analyst and you're asked to determine the value of a bond. The bond has a face value, a par value of $1,000, and the bond is quoted an annual interest of 12%, which is paid on a semi-annual basis. Again, remember, in terms of the interest you pay on a bond, how much you pay, it's based on the stated or quoted rate. In this example, you're going to pay interest based on 12% of the face value of the bond. Then there is also the yield to maturity on the bonds, which is 14%. Again, this is a yearly rate or annual basis, and there are 20 years to maturity. And then you are being asked to either again use Appendix B and Appendix D. And basically, again, Appendix A and D, one is giving you uh, the present value of annuity, that's the factor, and the other one is giving the present value of a single amount. Or you're also asked to use the financial uh, calculator or financial formula in trying to get an exact answer instead of being an estimate. So, given that, let me just draw this, and I'd like to use a timeline just to give us a picture of what is happening. So, in this example, what we know is basically this. So, we are talking about a financial instrument that in is going to mature in 20 years. So that's how we can represent this. So the key idea to determining the value or the price of a financial instrument is to be able to determine the cash flows and also determine our market rate or the yield rate per period, and also the nature or the value of the cash flows. So in this example, we know that this bond is paying interest on a semi-annual basis, and therefore every 6 months the bond is paying an interest. Every 6 months an interest. So you have an interest here, an interest at the end of year one, then an interest, 6 months, then at the end of the year. So every 6 months you are earning interest on this particular investment. And then when this bond matures, which is in 20 years, so at maturity, the bond will pay back again the face value, which in this case is per value, which is $1,000 at maturity. So at maturity, this bond is going to pay back $1,000. In addition to that, the bond is going to be paying interest every 6 months. How much interest are we talking about here? Now we are going to use the quoted rate or the nominal rate to determine the interest payment. Now remember, this is a bond that is paying interest every 6 months, and therefore the 12% that we've been given here is 12% per year. But we have how many payments per year? We have two payments per year, and therefore our interest payment is basically going to be the $1,000 is the face value times our rate per period. And our rate per period is the 12%, but we have two periods per year. So it's going to be 12 divided by 2, which is 6%, and 6% of 1,000. This will give us an interest of $60. So every 6 months, this instrument is paying an interest of 60 every 6 months. Again, keep on going until again at maturity it will also pay interest, and then it pays the first value. Now keep in mind the $60 you're seeing here, this is an example of annuity payments. This is why you're being given appendix A and B, because one represents uh, uh, the annuity factor and the other one represents the factor for a single amount. And then at maturity it pays 60. The 60 is a single amount. So in order for us to determine the present value or the value or the price of this security, we just have to discount the cash flows. We have to discount all the $60 to the present and discount also the $60 to the present, and of course sum them together, and that will give us the value of this instrument. Now to discount the payments, then we have to use the yield to maturity, or sometimes we call this the market rate. So you're going to use the market rate to determine to discount or to determine the present value of this back to the present. Here we've been given the yield to maturity is 14%. Again, it's 14% per year. And therefore, because this bond pays on a semi-annual basis, we need also to be able to use our yield rate per period. So again, in this case, we are talking about 14% per year, and we have 2 periods per year, and therefore our yield rate is going to be 7%, will be our yield to maturity. Again, this is per period. So to determine the present value or the price of this bond today's, at time zero, we are going to discount each payment again back to the present, and also discount the $1,000 back to present. Again, you could use any method to do so. I'm going to take you through how we use Excel, but you could use the tables as has been noted in the problem, or you could also use the financial formula. So if we end up using Excel, let me just show you how we go about this. Okay, I'm just going to put it down here. Again, I'm assuming you can see this. Give me a second. Let me try to. So to determine our present value of this bond, I'm going to put it up here. So the present value of this bond is going to be, I know the rate per period, again, we use the market rate or the yield rate to discount the payments. In this example, our rate is 14% per year, and per period is 7%. So we're going to use 7% as our rate to discount the cash flows. And then the number of periods we have here is the total periods. We know that we talk about 20 years, but then we have 2 periods per year. So in terms of the total periods is going to be the 2 again times 20, which is going to be 40. So our total periods are 40. And the payment here is how much interest we are paying per period. In this example, again, is $60 per period. So our payment is 60. And the future value, again, at maturity, it also is, the bond is also going to pay the face value or the par value. In this example, the bond will also pay $1,000. And you do this, and this gives us a present value, or the price in this bond should be 866 and 68. Again, if you just use one formula and you're done. You could also break this into 2 parts. What you could do, you could determine the present value of the annuity payments. That's where the appendix are coming from. you could use the table factor or even Excel to determine the present value of the annuity payments. And then next, you also determine the present value of the $1,000, and then you sum them together, and that still will give you the 866.68. So what you could do, just to show you quickly here, you could do this in two steps. So one is to determine the present value of just the annuity payments. That's the $60 every period for 20 years. In this example, again, our rate is still 7%. The number of periods, again, we're talking about I'm talking about 40, and the payment is 60. Again, we assume here there's no future value because we're breaking this into the annuity payments first, and then of course the single amount, the $1,000 later on. So again, we assume there is the future value is zero, and again we assume again these payments are at the end of the period. So by default, it's going to be zero, and then you just enter, and this gives you a value of I think I did the rest what I was doing. So let me go back. 799. But then you also determine I can just keep on going. Then also determine the present value of the $1,000 to be received in 20 years, which is in 40 periods. So this example again, our rate is 7. So the present value of the 1,000 number of periods again, the 40. The payment again in this case is zero because we already determined the present value of the annuity at 799 and 90, and the future value in this example, we know the first value of this bond is 1,000, and this will give us 66.78 as the present value, and you just sum this together, and this still will give you your value of this bond, which is again is the same thing as we did before, 866 and 68 cents. I'm hoping you get sense of how to go about this. In the second problem or part B, what we're being told, I think there's some modifications. So in part B, what we are given is that you have 15 years to maturity. So it's the same bond was for 20 years, but then you have 15 years to maturity, and something has changed, and that is the market rate or the yield to maturity has changed. And because it has changed, does it change the value of the bond? Of course, yes, because remember, we are using the market rate or the yield rate to determine the value of the bond. And that yield rate will keep on changing all along over the period of that particular bond. So in this case, you have 15 years to go, and the market rate changes to 10%. So what will be the new price of this bond? Again, in the same example, if we just put Excel, in this example again, remember what is happening is this. So if you have 15 years to go, again, remember the only thing that is changing in this equation is you have everything else. So everything else is the same as we just saw before. You still have to have 60 payments every 6 months, so that will still remain the same. The only thing that is changing is the yield to maturity. Instead of being 14%, it moves down to 10%, and therefore your rate per period is going to be 5% and not 7% as we are doing. That's the only thing that is changing. The payment will still be $60 because again we move from A to B, so the payments will be 60, but then the market rate changes to 5%. Given that reasoning, then how does this change the value of the instrument? So what you end up seeing is the same thing. So in this example, now the present value of this bond will be, we know that the rate changes from 14% to 10%, and therefore our rate per period is 5% because we still have 2 periods per year. And the total number of periods also changes because we have 15 years to maturity and we have 2 periods per year. and therefore the total periods remaining is going to be 15 times 2, and that will be 30 periods. In terms of payments, the payments will still be the same, which will be $60. And in terms of the future value, the future value is still the par value or the first value of the bond, which is $1,000, and all these payments again are at the end of the period. So you just ignore, or you can put zero there, and you enter, and this bond will be selling for $1,153.72. Now you can see the value of the bond goes up. So what does it tell you? If the yield to maturity, if the yield to maturity goes down, the price of the bond goes up. Basically, there's an inverse relationship between the yield to maturity, interest rates, and bond price. As the rate goes down, the price goes up. As the rate goes up, the price of the bond goes down. And in this example, again, we can see that's the reason, because the rate drops and the price goes up to $1,000 and some change there. So again, you could see that what ends up happening. So I hope this information helps. Let me know if you have any questions. But again, the key idea to solving these problems is to make sure you've identified the correct interest payment, and again, use the nominal rate or the stated rate or the quoted rate to determine the interest per period. Also important is to make sure that when you're discounting these payments, you're using the yield to maturity, or if you're given a market rate, then you use the market rate.